Hey math fans, welcome to the second half of section 2.5.2. Let's get started. In this section, we're going to be graphing exponential functions. We've already graphed exponential equations before, and so exponential functions aren't anything that are new, but we will be working with asymptotes officially. We will be discussing end behavior, and we will still be using function notation. Example 1, create a table of values for the exponential function f of x equals 3 times 2 raised to the x power plus 4. So the first thing you always do is create a table of values and be smart about creating this table of values. Include 0 as an x. That will give you your y-intercept. Take a look at what's going on in this particular table. The x's start at -4 and go to +4 pretty steadily. But what's happening to the y values? Look how quickly they are increasing. So there's probably an asymptote at 4 because notice how it gets closer and closer to 4 as x approaches -infinity. So the equation for the asymptote for this particular exponential function is y is equal to 4. Determine the y-intercept. The y-intercept is going to be whenever the value of x is equal to 0. So the y-intercept is 0, 7. As you can see, there is an asymptote here at 4. It's an invisible line that it's the value that y approaches as x approaches -infinity. In fact, that's going to be our end behavior statement. As x approaches -infinity, f of x, or y, the y value approaches but never is equal to 4. Okay, it approaches that asymptote. What's happening in this direction? As x approaches +infinity, what's happening to the f of x values? That's right, as x approaches +infinity, f of x will approach +infinity as well. Example 2, create a table of values for the exponential function f of x is equal to -1 times 3 to the x power minus 2. Again, identify the asymptote, the y-intercept of the function, plot the points, sketch the graph, and describe the end behavior. Something's going to happen here. Does anyone want to take a guess? What's going to happen because there's a negative value in front of our exponential function here? Any guesses? As you can see, x is getting larger as x approaches +infinity. What's happening to the f of x values? This graph is going to be going through 0, -3, but notice how it's going to go to -5 and then -29. It's approaching -infinity in this direction. And it's probably going to smooth out and approach an asymptote in this direction. Do you want to take a guess what the asymptote is? So the asymptote for this one is y is equal to -2. What about the end behavior statements? As x approaches +infinity, f of x approaches -infinity. And here's another example. Again, make a table. As you can see, I've made a table for this particular function. F of x is equal to -2 times 1/4 raised to the x power plus 5. You can take a guess where the asymptote will be as it starts to approach a number. Notice when you start to see it go from like -27 to -3 to +3 to 4.5 to 4.8, it'll probably go to 4.9, 4.99999. The asymptote is most likely going to be 5. So at y is equal to 5 is probably your asymptote. And that's happening as x is increasing towards +infinity. Has anyone picked up on the pattern yet? 5 is the asymptote. In the previous problem, 2 was the asymptote. It almost seems like the asymptote is always consistent with that number right there. Let's write a couple end behavior statements. So as x approaches positive infinity, f of x is going to approach what? That's right, 5. What about the other end behavior statement? What about this other end behavior statement? Well, as x approaches negative infinity, f of x will approach negative infinity, won't it? And that's going to do it for section 5.2. We'll see you in class.